Okay, so today is February the 8th. Today is February the 8th. Um, we're going to do the warm up, or you've already been working on the warm up. Okay, then I'm going to go over how to find teacher model. And today we're finding um, growth rate, growth, decay rates, or percents. And then there's an activity that goes with that. Okay. The activity is for grade, so we need to make sure that we complete that. I'm going to give you a little time tomorrow. You have homework. I think I'm going to make another help video tonight. Don't forget about your tutoring tomorrow. Your planner, let's write down the homework in our planner, please. We're in week 3. I'll pause for the calls here. All right, don't forget that your planner is a grade. I want to make sure we have this written. And I'm writing your class in blue. If you did your homework and you please check it off. You worked on already last night, check it off. You have Math 1 homework tonight. And there is a help video for that. Okay? Work on already if you haven't already. Remember, your already project is due February the 18th. We have a quiz on Friday. We have our math assignments due on Friday as well. Okay? Now pause for the calls. All right, so let's look at our warm-up. Tuesday, we're dividing. All right, so we're going to look at our coefficients first. Those are the numbers in front of the variable. So we have 22 divided by 2. What's 22 divided by 2? 11. So we got 11 first. Good job. Now let's look at our variables. So we have y to the 6th power here and y to the 1st power. If you don't see an exponent, it's automatically 1. You are dividing exponents that have like bases. You subtract the exponents. So that's going to be 6 minus 1. Okay. Then we have the z's. It's a z to the 8 and z to the negative 7. So we have z 8 minus a negative 7. When we simplify this gives us 11. Y to the what power here? 5th. Z to the what power here? Raise your hand if you got that right. Excellent. Okay, so let's look at the second problem. The population of Jose's town in 1995 was 2,400 or 2,400. The population in 2000 was 4,000. Let X represent the number of years since 1995. Okay, so 1995 is the 0 year. Okay, so they gave us basically 2 ordered pairs. The first ordered pair is the 0 year, and the population for that 0 year 1995 is 2,400. So this is X1, Y1, right? This is the first point. The second ordered pair that they give you, how many years after 1995 is 2000? So we got in the 5th year, the population is 4,000. So this is X2, Y2. So now we're writing a linear equation. They didn't give us the slope, but they did give us 2 ordered pairs. So we need to find M first. So we're using the slope formula, Y2 minus Y1 over minus X1. So on the top, what do we get? What minus what? Very good, babe. 4,000 minus 2,400. Great job. Okay. What are we going to get on the bottom? What minus what? Very good. 5 minus 0. You write this down? Okay. So now on the top, what do we get here? What's 4,000? Type it in if you can't do that in your head. We got 4,000. Oops, sorry, y'all. Minus 2,400. What does that give you? Very good. 1,600. 1,600, right? So M, we got 1,600 on the top, and what on the bottom? 5. Let's simplify that. 1,600 divided by 5. What does that give us? What does that give you? 320. 320. So your slope here is going to be 320 people per year. That's going to be the slope, 320. So now we need to find B. What's going to be your B in this problem? B is going to be equal to what? What's your starting amount? 2,400. Okay? That's your starting amount. So now how do we write the equation for this problem? Y is equal to what? 320 plus 2,400. Very good. Did anybody get that on their own? A couple people. Okay, that's great. All right. Okay, let's make sure we put this in our folder so that we don't lose it, please. And let's take out our booklet. Anybody still copying before I move this away? You got it? All right, I'm going to move this out the way and pause for the calls. All right, remember the best way to retain information is that you spend just like 2 or 3 minutes when you get home or later on just reading over what you wrote that day. You'll be surprised at how much your brain will retain when you just take 2 or 3 minutes out of your day to review something that you did that current day. Okay? All right, so this is what we did on yesterday. Okay? We talked about the difference between linear and exponential functions. Okay, then we wrote the equations or forms for exponential function. The standard form for exponential function is a times b to the x power, where your x is your output, dependent variable, f of x range. It's consistent in all functions. Your y in all functions is always your input, your dependent, your domain. In exponential functions, the a is the starting amount or the y-intercept. The b is the common ratio. Okay, it's the number that's being multiplied to get to the next number of these sequences. Okay. Exponential growth is where your b, your common ratio, is greater than 1. Exponential decay is when your common ratio is less than 1. In exponential growth word problems, that sometimes they don't give you what the common ratio is going to be. Sometimes they'll give you the percent. They'll say it increases by 20%. Then you use this formula because R represents the percent. They don't always give you common ratio. Sometimes they give you percent. So if they give you the percent, you don't just put 25 here for 25%, you put 0.25. You always change your percents to decimals before you substitute them into formulas. Okay? The same thing with decay. They're not going to always give you in these word problems, they're not always going to say that the common ratio is 3. Sometimes they'll give you the percent. Okay? They may tell you that it decreases by 50%. So you use this formula and you plug in 50% for R as 0.50 or 0.5. You always change your percents to decimals. Any questions about anything I said here? Okay. Do not forget that B for exponential growth is equal to 1 plus R. And 1 plus R is equal to B. So if they give you the common ratio, you can find the rate in which the percent in which it increases by using this formula. Don't just say if your B is 3 that it increases by 3%. No, that's not the way that works. You have to substitute 3 to figure out what the percent is here, and you use this formula. Okay, and we're going to do that in a minute. Compound interest, the only reason why these letters change is because with compound interest, you're dealing with money. So your P is the same as A and C. It's your starting amount. And what's in the parentheses? This is the same as B, your common ratio. Okay? Only in compound interest problems, they're going to give you a percent that it increases by, and they're going to tell you how many times interest is going to be charged in a whole year. Interest is going to be charged multiple times in a year. So that's what that N represents. And don't worry, when we get to problems like this, I'll reiterate this again. Okay? For today, we're going to do how do you find the growth and percent rates, the percentage, how much it increased, the percent of increase, the percent of decrease in exponential and exponential growth and decay functions. All right, so the formula that we're going to use to find the growth rate is going to be B is equal to 1 plus R. This is how you find the rate or the percent that it increases by. Okay, so I'm going to give you an example. Let's suppose that the equation that they give you, the exponential function, is y is equal to the starting amount. Let's make it at 3 times 2 to the x power. We want to know what percent did it increase by. This is the common ratio. Okay, that's not the percent that it grew. That's your common ratio. A is going, I'm going to put this out to the side for you. A is going to be 3. That's your starting amount. 2, B is going to be 2. That's your common ratio. And sometimes they call this the growth factor. So this is either common ratio or growth factor. It's the number that's being multiplied to get to the next number. Factor means multiply. So it's our common ratio or growth factor. We don't want to know those. We want to know the percent that it increased. So this is how you find the percent. And a lot of people miss this question because they just look at 2 and they roll with 2 and say it increased by 2%. That's not the way it goes. So let's solve it. We're going to plug in. We're going to substitute. I'm sorry, y'all. We're going to plug in B into the equation. So our B here is 2. And we're going to solve for R. That means we have to get R. We have to get R by itself. So what do we do to get R by itself? Subtract 1. So when we subtract 1 from both sides, what does that give us on this side? That gives us 1. So R is equal to what? This is the decimal. This is the decimal. How do we go from a decimal to a percent? We move the decimal over 2 places to the what? 2 places to the right and add a percent sign. So it's 100% increase. Any questions about that? Okay. Let's do exponential decay. Anybody still copying? Do I need to pause? Okay, I'll wait a second. All right, here we go. Let's do this one. Exponential decay, the rate, what I'm talking about here is the percent that it decreased. Put percent here so you don't forget. Okay. The decay rate or percent is going to be the formula. B is equal to 1 minus R. Sometimes they want you to keep it as a decimal, okay? But sometimes they want you to write it as a percent. So that's why I did both. So let's do this one. Let's do the example here. The example is, let's do y is equal to, let's make our starting amount 4. And let's do b has to be smaller. You see that has to be smaller than 1. So let's do 1/4, okay? To the x power. All right, so again, out to the side, I'm going to write my starting amount is 4, okay? My common ratio or my decay factor is going to be 1/4. This is what I multiply to get to the next number. It's not the percent decrease, it's just the amount that's being multiplied to get to the next number. It's not the percent that it decreases by. It's called, this right here, this number right here is called our common ratio or our decay factor. Okay, so I'm gonna write it again. Common ratio or decay factor. The number that's being multiplied to give you the next number in the list. Anastasia, you okay? You sure? Okay. Yes. Yes. All right. So now the formula that we use, we're going to substitute the value for B. What that was? Sound like a pig. All right. So we're going to replace B with 1/4. Yikes, y'all. So now we got to get R by itself. So how do I get R by itself? Yes. Add 1 to both sides. Oops. I don't know why I put equal right there. So we got, when we add 1/4 plus 1, what is that? Let's write it as a decimal because this is a rate. What does that give us? 1.25. Bring it. Go ahead. What was you going to say? Wait, did I answer right? Oh, we subtract. Why did we add? Why did we add? I don't even know. Oh, that's all right. I don't know why we add. So let's subtract. What does that give us? Negative. Don't forget. Say again. Bring down the what? The 1. Negative R. Negative R. Good job. So now how do we get rid of the negative? Multiply R. Divide by -1. -1. We want the R. We're just trying to get rid of the negative. So this is going to give us point what? 0.75 is equal to what? R. Okay, so now what does this mean? What percent is this? 75%. This is a 75% what? Decrease. Any questions? Sometimes they want you to keep it as a decimal, and other times you'll see the answer written as percent. They won't have both of them as the answer choice, okay? They'll have one or the other. They won't put the answer 0.75 and then also have down there 75% because they're the same thing. Any questions? That's right. Okay, anybody lost? All right, so this is practice right here. All right, this is practice right here. So look, this is exponential growth. This is exponential decay. Look, you see how they put A here? That's the same as C, A, C. Sometimes you'll see A, sometimes you'll see C. Please don't get tripped up over that. It's the starting amount, okay? All right, so let's look at this equation right here. What's going to be in this equation right here? 2 times 1.43 to the x power. 1.43 is greater than 1, so it's exponential growth, okay? What's the growth factor in this equation? Which one of those numbers is the growth factor? 1.43. Any questions about that? Yeah, baby. What question? Oh, okay, never mind. I see. You sure, babe? Yeah, I got it. Okay. I didn't see the exact word. Okay. Donnie, y'all okay back there? Who's that? Ian, you're running your mouth? Stop, please. All right, here we go. Let's find the growth rate. So to find the growth rate, we have to use the formula. Don't put this down for the growth rate. They're asking you for the percent. Okay? And we're gonna keep the percent as a decimal in this one because it didn't say that they wanted it as a percent. So I'm gonna use this little sheet right here in the back. And I'm gonna say B is equal to 1 plus R. So now I'm gonna find the rate or the percent. My B was 1 point what? 43. 1.43. Very good. Now I need to find the percent in which it increased by, not the growth factor, but the percent. So we got to find R. How do we get R by itself? Subtract 1. Subtract 1. When we subtract 1 on both sides, what does this give me here? You get 0.43. And on this side, what do you get? R. So this is the decimal. How would I change this decimal to a percent? Move the decimal 2 places. And so what percent would this be? 40% what? Increase. Any questions about how we got that? Okay, so it's 0.43. What's the initial value in this equation? 2. Any questions about how I did that? Let's look at decay. What is the decay factor of this equation here? 0.75. So now we need to define the decay rate. So we're using B is equal to, what's the formula here? 1 minus R. And we're going to plug in B. Do you see how you get so sidetracked so easy? You just go to the left. All right, what's going to be our B? 0.75. So now we got to get R by itself. How do we get R by itself? Subtract 1. There we go saying that add again. That messed us up last time, didn't it? Come on, sorry. All right. What do we get here? This is gonna be a negative what? Negative 0.25. Negative point what? 25. 20. It's all right. So here, what are we gonna get on this side? Negative R. Negative R. How do we get rid of the negative? Divide by negative 1. So what's this gonna give us here? 25 is equal to R. Oops, sorry. 0.25 is equal to R. How do we write this as a percent? 25%. This is a 25% what? Decrease. It decreases by 25% every time, okay? So this is 0.25. All right, what's the initial value here? 300. Anybody lost? Anybody lost? All right, good deal. Okay, so this sheet, let's look at this one, and I'm going to give you a little time to complete this tomorrow. I'm going to explain it. You'll be all right. Okay, so what you're going to do is you're going to read the problem, and you're going to decide if this problem is growth or decay. Then you're going to decide what the growth rate is. I told you how to find the growth rate, okay, or the decay rate. You're either going to use B is equal to 1 plus R, or B is equal to 1 minus R, okay, to find that. The change factor, whether it's going to be whatever your B is, the initial value is your starting amount, and you take these two amounts to write your equation. The numbers and the answers are up here. So you cut these out, and you paste them where they belong down here. Questions, comments, or concerns? Anybody? Yeah, we won't have time to start that today because what time we leave here? 15. So that's like 3 minutes. Okay. Any questions about the direction? So tomorrow after we finish our warm up, you need to do this. Yes. I just said that. I said that. Yeah. Tomorrow. Come on, Donnie. Anybody else? Any relevant questions? Shh.
What does the MOD mean? Next to the
What? Where am I at?
at the top where it says like her name and whatnot. What's MOD?
I don't know what that is. All right, I'm gonna go ahead and stop the video.